Okay, so let's start from the beginning. So a quadratic relation is modeled by a smooth symmetrical curve known as, what do we call it? What do we call the shape?
Parabola.
So the key features of the parabola are the following. The zeros. So I've asked you where would the zeros be, and you guys said that it's wherever the graph intersects the x-axis. There's many names for the zeros. I'm going to list them. So this way, when the question is asking you to find the x-intercept, you know what you're finding. If the question asks you to solve, you know what you're finding. If the question is asking you to find the roots, you know what you're finding. All of these words mean the zeros. They all basically are asking you to find the zeros. So zeros, x-intercept, roots. Also, if the question is asking you to solve, you need to find the x-intercept or these zeros. So the x-intercepts are these 2 points right here. So this point and this point. So that's when the graph is intersecting the x-axis. Now, I don't always have 2 x-intercepts. Sometimes I have 1 x-intercept, and sometimes I don't have any x-intercepts. Depends on the location of your quadratic, of your parabola. So I'm going to show you an example. So if I have something that looks like this, how many x-intercepts do you have? One, right? And it's located right here at the vertex, right? So in this case, you only have 1 x-intercept. Now, what if the function looked like this? How many x-intercepts do you have? None. Okay? So the most that you can have is 2 x-intercepts, and you can have 1, and you can have none. Okay? Now, how do I write the x-intercepts? So whenever I find my x-intercepts, how do I write them? How do I refer to them? So you can refer to them with the following. So x equals 2, and then you write the values. But when you write the value, I'm going to use 2 letters. I'm going to use R and S. And you will know what is R and S because when we look at this formula, you will know why I refer to them as R and S. Okay? So we call them, so the x equals R and S. So this is how you're supposed to refer to them. Okay? So let's say this x-intercept is -1 and this x-intercept is 3, right? You're going to say x equals -1 and 3. Okay? So this is one way you can refer to them. I'm going to write the example here. So it's equal to -1 and 3. Okay? The notation is very important in math, the way you write them. Because there is a difference if you write this or if you write this. This represents a point, which we don't have that. It's not a point, it's 2 separate points. Okay? So that's why we have to note it properly. Alright? Now another way that you can write this, and you guys can pick and choose which way you want to write. You can write it as R0 and S0. Okay? So basically I can write this as -1, 0 and 3, 0. Okay? Now, this is called a point notation, so I'm using the points, right? And this point right here has an x value of -1, and a y value of 0. This point here has an x value of 3 and a y value of 0. Whatever is easier for you, okay? You have the choice to pick between this notation or this notation.
The top one, if you're marking it instead of R0 and S0, -1 and -3, is it either one way or the other?
So you can write 3, 0, and
either way, either
mean?
way on the top one. R equals R0 and is that the full equation? There's 2 lines at the top.
So you don't have to write this, right?
Okay.
When you're given an example,
Right.
you're gonna just write this, okay?
Yeah.
Or you're gonna write this, right? You're gonna pick between these two. This is the general form I'm writing for you because now in this example it's -1 and 3, but in other examples it's not gonna always be -1 and 3.
But that's the actual question.
That's the solution of this actual question. Okay? Now, the order of the -1 and a 0 is important. So you can't write 0, -1 because then it's not the x-intercept anymore. Okay? So that's why I always say if you're not 100% sure which one goes first, write it that way because that way you won't make the mistake. A lot of students who pick this and they don't know how to use their points, they write this instead, which is incorrect. Okay? So if you're not sure which one goes first, go with the easier format. Okay?
And you always start with it, then R accounts for.
Doesn't matter. R and S, they're just letters.
Oh, we're not.
Okay, so let's explain. So the x-intercepts are where the graph intersect the x.
I think it might be a good idea to color code what isn't important, like the R, O, and S0. Maybe color code it with a red.
So this one, so these two?
Yeah.
So these two?
Or like even from now on, whenever there's something that's not relative, it is, but it isn't. Just color code it so it doesn't confuse some people.
And that's like, I have to, in this case, I have to give you both.
I know.
I'm teaching you that, I have to teach you the general format, right? And then I'm going into specific for that specific example, right? So I have to write both of them. I'm gonna highlight the solution. So this is the solution of this specific one. How's that?
Yeah.
Okay? So the one I highlight would be the solution of that specific example.
Why are we looking for X?
Because the question is asking you to find the x-intercept or find the zeros.
And you're saying that -1 and 3 is equal to 0?
So this is when, so this one right here, -1 and 3 is when your graph intersects the x-axis.
Why? I'm still not understanding why X is there, X.
Because if you're looking at that point right here, let me just make it bigger. Right? That 3 belongs to what axis? The x-axis or the y-axis? Right? It's the x, right? So when you're writing that the x-intercept, you're gonna write it as an x. X equals to 3, right? You're gonna have to name it.
Okay.
It has to have either x or y.
I'm still just not understanding why it's grouped under zeros.
Oh, because, okay, I know what you mean. Why is it zeros? Because at this point your y value is 0. So this is a name for it. They
Y
named
value is 0?
Yeah, at this point, yes.
But we haven't even spoken of the y.
Yeah, but what is this point? Tell me what the value of this point is.
Okay.
Right? The value of this point is 3, 0.
0.
Right?
Okay,
So
yeah.
they're called the zeros is because that's when your y is 0.
Okay.
Okay?
Yes.
So you're looking for the x value
That's what I was
when y
looking
is 0.
for. Thank you.
Okay?
Also, Miss Amber, another question. Like, if the R is always on the negative side and S is for the
No,
positive.
it doesn't have to be. Sometimes it can be both on the positive. Sometimes it can have be both on the negative. R and S, the order of them doesn't matter. They're just letter.
Oh,
Okay? Just so we make it, we use R and S to make it general. Okay? Because if I just use the numbers, right? I'm gonna give you another question, and that question is gonna be this. Now your zeros are not -1 and 3 anymore, right? So if I don't use a general letter, right? You're gonna think that the answer for the x-intercept is gonna always be -1 and 3, which is not correct. Make sense? Okay. Now, so we talked about the x-intercept or the zeros. Now we're going to talk about the y-intercept. So this graph, where's the y-intercept for this graph? At -4. So if you look right here, right, this is the y-intercept. Correct? Okay. There's only one name for the y-intercept. Unless we get into problem solving, we'll talk about that later. Okay? So this y-intercept, you can write it also in two ways. So you can say y equals to, and I'm going to use the letter C. The reason why I'm going to use the letter C is because, again, later on, we're going to talk about the standard form, and then it belongs to this C. We'll talk about that later. Okay? So, and then for this example, it's going to be y equals -4. Right? Because it belongs to this value right here. There's another notation. You can write it as y equals, or sorry, you can write it as y-intercept is, you write 0, -4. So that's the solution for this. Or you can write it in general format, it will be 0. Okay? Now, look at this point right here. This point is at -4. What is the actual point for it? What's the x value at this point? The x value at this point is 0, and the y value is -4. Okay? That's why I can write it as 0, -4, or I can just simply say y equals -4. That's my y-intercept. Okay? So again, you can pick between these two formats. Whatever is easier for you.
So why is it okay to write 0, -4 and here and not up there? 0 wasn't first up there.
Because this is a y-intercept. So in this case, in the y-intercept, your x is 0. Right? Your x is 0 at this point. In this case, your y is 0 and your x is 3. Okay? It's going back to finding points on the grid. Understanding that points on the x-axis have a value of 0 in the y. Okay?
And you need to write this y is equal to c.
This is a general format. Okay? So, remember that in this question, the y-intercept is -4. But in other questions, it's not going to always be -4. Right? Make sense? So that's why we use the general format. important point. That is your turning point. Okay? So in this case, yeah.
You named the, like in here, it's intercept with a graph and y-intercept with a graph. Shouldn't it be, I had the word, plot? Shouldn't it be plot instead of graph?
When okay, this is a graph because it's specific.
I thought the grid is the graph, no?
No,
okay.
The grid is the grid. Graph is actually the graph, right?
So
and
that's
then
two words, it's also
there's two
plot?
words. Plot is more like a sloppy graph, right? A plot you don't have to have exact 100% exact values. A graph, it will be an exact value. Okay, that's the difference between. So when I tell you plot, I'm not looking for all the exact 100% exact value. When I tell you graph, it has to be very accurate.
Thank you.
Okay. Now, I'm just gonna make this a little bigger so we can see. Vertex. Vertex is our turning point. So in this case, I have two different graphs, right? So where is the vertex for the first graph?
1 and -6.
So it's right here, right? Yes. Okay, that's the vertex. The vertex in this case is at 1 and at -6. Do you guys agree with that?
Yes.
Okay, so the point right here is going to be 1, -6. A vertex is a point. So that means a point always have x and y values in brackets. Okay? A point has to be x first, comma, y in brackets. Now, where would be your, I think that's flipped, I don't know. Okay, where would be my vertex here? 4. It's 1 and -6 as well, because that's -5, -6, -7, -8, -9, -10. Okay? So this is only taking this part of the graph down here. Okay? So that's also 1 and -6. -5, -6, 7, 8, 9, 10. Are you guys okay with this? Okay. So this point is also at 1 and -6. So, the general format of a vertex, we write the letter H and K. And the reason why it's H and K, can I have your attention here for a second? Is because of this one. I keep going back to these 3 colored sheets. These 3 colored sheets, they represent quadratic equations in 3 different forms. So one quadratic graph can be written in 3 different formats to make things harder, right? They have to, right? So the formats are called factors form, standard form, and vertex form. We're gonna talk more in detail about these forms and when to use what, and how to go between different forms, okay? Now, as you can see, the factored form, I was able to indicate the zeros or the x-intercepts, right? I told you it's R and S, right? In the standard form, I showed you that C is the y-intercept. In the vertex form, there is H and K, which indicate your vertex. That's why it's called a vertex form. We're going to talk in a lot of details about each form, okay? So I don't want you overthink it right now, because I'm going to explain it. I'm going to explain it over and over again, so that's totally fine, okay? But I want you to understand, why am I using these letters H, K, C, R, S? Where am I getting these letters from? It's just to stay consistent with the formulas given to us in the 3 different forms. Okay? So the vertex is labeled as HK. H represents the x value, and K represents the y value of the vertex. Okay? So these are the specific examples, and this is the general format, the H and K. we okay with this? So far we talked about the x-intercept, the y-intercept, and the vertex. Okay? The fourth thing that we're going to talk about is the axis of symmetry. So we said yesterday that the axis of symmetry is the imaginary line, right, that cuts the graph vertically in half, right? Because symmetry means when you fold it on top of each other, they're going to be 100% matched, right? So when I'm looking at an axis of symmetry, I'm looking at this imaginary line. So it's the line that cuts your graph in half, so it's that vertical. Okay? So axis of symmetry is written as an equation, and it is written as such. X equals to, now if you look right here, what is the x value that the axis of symmetry passes through? It passes through 1. Can you guys see that? So my axis of symmetry passes through the value 1. Okay? So it's equal, so in this case, x equals 1. Okay? So this is the equation. Of to shorten axis of symmetry, I will say AOX. Axis of symmetry. Okay? So I don't have to write it every single time. Okay? Now, this vertex is the same as this, right? Let's go back to our previous question, right? Where I looked at the vertex, right? This value 1 is the same as the x value of your vertex. You guys see that? Why is that? Because my axis of symmetry passes through the vertex, right? Do you see that?
Yeah.
Okay. So it's always going to be the case. If you know your vertex, the axis of symmetry is going to have the same value of the x value of your vertex. Okay? So if the x value of my vertex in general form was h, what would be the equation of the axis of symmetry in general form? X equals h. Right? So that's the axis of symmetry in general form. And this is in the specific example. H stands for the x value of the vertex. That's it. It's not. It could be highest or lowest, so that's why we don't both. So H is the x value of your vertex, which is this, which is the same thing as the axis. Okay? So it's an imaginary line of symmetry that runs vertically through the vertex. Right? It passes through the vertex. talk about is called the optimal value. Can you guys tell me what the word optimal means? Optimal. Anyway, optimal. What does optimal mean?
Yes.
The highest or the lowest. That's your optimal, right? Technically you want it to be the highest, but sometimes we don't have the highest, right? So an optimal value means it's either your highest value or your lowest value, right? So if I'm looking at this, my highest value or my lowest value case is -6, right? So your optimal value is the y value of the max or min. Okay? So let's go back to what point does this belong to? So that -6 belongs to what point? The vertex. It belongs to the vertex. I'm still talking about, I'm looking at the vertex, and I'm looking at the y value of the vertex, right? So if I look right here, the y value of the vertex, I gave it a letter K. So that means general form, I'm gonna look at this as y equals to K. So this is gonna be the general form. So axis of symmetry is the x value of the vertex. The optimal value is the y value of the vertex. Let me write that down. So the axis of symmetry is the x value of the vertex, and the optimal value. Guys, can you make sure that this is written very clear on your notes, and then this is highlighted, because you're going to hear me say that again and again and again and again and again and again. Okay? The optimal value is the y value of the vertex. Okay? So my vertex is is h and k. The axis of symmetry is this. And the optimal value is this. Do you need to, let me just do something. Do you need the bandage?
At least we need to probably clean that out. God knows where the